Welcome to Sujitra's statistics classes. Today we are going to discuss about Bernoulli distribution. The Bernoulli distribution, named after Swiss mathematician Jacob Bernoulli, is a discrete probability distribution of a random variable which takes the value 1 with the probability p and the value 0 with the probability 1 minus p. X is a discrete random variable with values x equal to 1 with probability p and x equal to 0 with probability 1 minus p. That is, p of x equal to 1 is p of x equal to 0 is 1 minus p for x equal to 0 and 1. Therefore, f of x is p raised to x 1 minus p raised to 1 minus x. Let q equal to 1 minus p, then Pm of x is f of x equal to p raised to x q raised to 1 minus x for the values of x equal to 0 and 1. Therefore, f of x is equal to p raised to x q raised to 1 minus x for x equal to 0 and 1 equal to 0 elsewhere. P is the parameter of a Bernoulli distribution. Q equal to 1 minus p and 0 less than or equal to p less than or equal to 1. Now, let us think about the distribution function capital F of x, which is equal to probability of capital X less than or equal to small x, cumulative density function. For a Bernoulli distribution, f of x equal to 0 if x less than 0, equal to 1 minus p if 0 less than x less than 1, equal to 1 if x greater than or equal to 1. The Bernoulli distribution is a special case of the binomial distribution with n equal to 1. The Bernoulli distribution is simply B1P. And we can write this Bernoulli distribution as x follows Bernoulli PP in bracket. Now, let us think about the rth row moment about origin mu r dash. What is the use of calculating rth row moment about origin? By the calculation of mu r dash, we can calculate all other characteristics of any distribution. That's why we are interested in the rth row moment about origin. Mu r dash is equal to expectation of x raised to r. Mu r dash is equal to expectation of x raised to r. Being a discrete random variable, this is equal to summation over x raised to r, f of x. Here x takes the value 0 and 1. F of x equal to p raised to x q raised to 1 minus x. Therefore, mu r dash is equal to summation 0 to 1 x raised to r p raised to x q raised to 1 minus x. Which is equal to p. Irrespective of the grade of row moment, it is p in Bernoulli distribution. That is a speciality. Now, let us think about the direct way to calculate row moments. Mu1 dash, which is equal to E of x, is equal to summation over x fx. That is sigma 0 to 1 x p raised to x q raised to 1 minus x, which is equal to p. Then mu2 dash is equal to E of x square is equal to summation over x square f of x. That is equal to summation 0 to 1 x square p raised to x q raised to 1 minus x, which is again equal to p. So mu 1 dash equal to p, mu 2 dash equal to p. Then arithmetic mean mu. What is mu? Mu is e of x. Mu 1 dash itself is mu, which is equal to p. Variance mu 2 is equal to variance of x is equal to expectation of x square minus e of x whole square, that is p minus p square. Take 1 p outside. So we are getting p into 1 minus p. And we know that 1 minus p equal to q. So variance of x equal to p into q. Then standard deviation. What is standard deviation? It is root mu 2, which is equal to root pq. Then moment generating function. Why we are calculating moment generating function? Moment generating function can generate moments. And its notation is mxt, and its definition is mxt equal to expectation of e raised to tx, which is equal to summation over x e raised to tx fx, which is equal to summation over x e raised to tx p raised to x q raised to 1 minus x. That is summation 0 to 1 e raised to tx p raised to x q raised to 1 minus x, which is equal to q plus p e raised to t by substituting the value 0 and 1 for x. So mxt is equal to q plus p e raised to t. Then characteristics function that can be calculated in the same way as that of moment generating function. Characteristic function phi xt is equal to expectation of e raised to itx summation over x e raised to itx fx summation from 0 to 1 e raised to itx p raised to x q raised to 1 minus x. So this is equal to q plus p e raised to it. So characteristic function phi xt equal to q plus p e raised to it. So at a quick glance, if x follows Bernoulli p, probability mass function f of x equal to p raised to x q raised to 1 minus x equal to 0, 1. P is the parameter of Bernoulli distribution. Q plus p equal to 1. 0 less than or equal to p less than or equal to 1. Arithmetic mean mu equal to p. Variance mu 2 equal to pq. Moment generating function mxt equal to q plus p e raised to t. Characteristic function phi xt equal to q plus p e raised to it. The graph of PMF of Bernoulli distribution. The graph is two adjacent bars and it depends upon the value of p. If p is 0.5, the values are f of 0 equal to 0.5 and f of 1 equal to 0.5. So the graph will be like this. If p equal to 0.4, f0 is 0.6 and f of 1 is 0.4. Then the graph will be like this. If p is 0.06, then f of 0 is 0.4, f of 1 is 0.6. Then graph will be like this. Now, in experiments and clinical trials, the Bernoulli distribution is sometimes used to model a single individual experiencing an event like death, a disease or disease exposure. The model is an excellent indicator of the probability a person has the event in yes or no questions. Bernoulli distributions are used in logistic regression to model disease occurrence. It is also a special case of the two-point distribution for which the possible outcomes need not be 0 and 1. That can be 5 and 7, 2, 3, whatever be the value we are assigning to x. So, thank you for watching this. If this found to be useful, then like and subscribe Suchitra's statistics classes.